Okay, next page is how a voltaic cell works. So you've got two beakers. In the first beaker, you're going to put zinc metal. In the second beaker, you're going to put copper metal. Each of those beakers, if we're in zinc metal, needs to have zinc ions in solution. And the copper metal needs to have copper ions in solution. The anion doesn't matter because it's just something to get the cation into solution. We hook up a wire from one metal to the other. This is our anode. This is our cathode. And then electrons flow from the anode to the cathode. Those are your electrons flowing. There could be a light bulb here. And since electrons are flowing, then the bulb will light. And the electrons flow through the wire. So the electrons are actually in the wire. All right. Also included in your cell is something called a salt bridge. This is something that has a salt, an ionic compound, something that's always soluble. So we're just going to use potassium acetate. And then the salt, since it's in solution, breaks up into ions, like everything else in solution, breaks up into ions. So what happens is the electrons, zinc metal, oxidizes and forms zinc 2+, and electrons flow. Zinc metal oxidizes, forms zinc 2+, and electrons flow. And when the zinc metal oxidizes, it actually, the zinc metal bar actually dissolves. It goes away. So it gets smaller. It gets smaller. And then the electrons are flowing. They're flowing, and they come to this side. So this side gains electrons. When this side gains electrons, it combines with the copper in the solution, and copper solid starts forming on the metal. So this one gains mass. The cathode gains mass, and the anode loses mass. The salt bridge, so what you notice in the anode is that there's a buildup of positive ions. The more zinc gets oxidized, the more positive ions build up. So the more positive ions we have, the negative ion from the salt bridge will go into that beaker. Because if all of these ions are positive in the anode, then the electrons aren't going to want to transfer anymore. And so to maintain a neutral environment, the salt bridge, the anion from the salt bridge moves in here. So you start getting some acetate. Same thing happens in the cathode. All of your positive ions are going away. So all you have left in your beaker are your negative ions. So you get a buildup of negative ions. To balance that buildup, the positive ion from the salt bridge has to go into the beaker. If you notice, the positive ion is the cation and goes to the cathode. The negative ion is the anion and goes to the anode. The actual reaction happening was zinc was being oxidized, copper was being reduced, goes to form zinc 2+ plus copper. That's the actual reaction, and it does not match the beakers. Students tend to get confused because the zinc and the zinc 2 plus are in the same beaker. That doesn't mean they're both reactants. Your zinc is a reactant and your zinc 2 plus is a product. Same thing with the copper. So the picture doesn't always, the picture can sometimes be tricky to interpret.